as we've talked about, when we have two similar figures, in addition to knowing that any pair of sides are going to be in the same proportion, called the scale factor, image over pre-image, we talked last class about the fact that the perimeter, 4 times 3 is 12, the perimeter here, 5 times 4 is 20, would also be in that same ratio. If I reduced it by saying this is 4 times 5 and this is 4 times 3, the perimeter would be in the same ratio, the same scale factor as any other length measurement. Turns out that's true for like diagonals or from the center to the edge, perpendicular, such that in polygons that are similar, all corresponding length ratios are in the same proportion. That means that if I do something like an altitude of a triangle, going from the top perpendicular to the side, from the top perpendicular to the side, that I can expect that if I create a ratio of corresponding sides, like AB over EF, that ratio would be the same ratio as these special segments, like altitudes, BD over FH. They're in the same proportion. And if I did something like an angle bisector, coming out of an angle, splitting it exactly in half, that's a special segment. Therefore, if I start with a segment pair, like QP and UT, corresponding, that ratio, the scale factor, would be equal to the same ratio of those special segments. So in this case, what would I put here? QS over UW. Good. Can you please do a proportion for the medians? I get a volunteer to share with us. Does it matter which side pair we pick? First one's free. They just have to be matched. So we could choose GH, and if we did, what would be the side that matches to that? KL. Now we've locked it in place. We're saying that this one is first, it's on top. This one is second, it's on the bottom. And we're saying that these medians from this vertex to the midpoint of the side. So where should I put HJ, top or bottom? Top, because it's part of the GH triangle. And what matches from this other triangle? LN.
This work with
I could have said for the side length, I could have said that HI over its corresponding pair, LM, is equal to either GH over KL. We saw that last time. Or we could say HJ over LN. Or we could say GJ over KN, right? Any pair of corresponding length components would be in the same proportion. So let's take a look at number one. We're going to set up a proportion. I know it's going to be a fraction equals a fraction, a ratio equals a ratio. The question is, what do I match up? Well, what are we looking for here? There's an X. So what's X going to match up with? I think X is this length. It's a median, right? It's going from a midpoint, excuse me, from a vertex to a midpoint of a side. So what matches with that? 15. That's also a median. So I could say that X over its matching piece is equal to what?
16 over 24.
16 over 24? You guys agree with that? I like 16, but I don't think it matches with 24. Why not? It's not the littlest, right? These two, 16 is smaller than 19.2, so I should choose the smaller of these two. I should choose 20. Those are corresponding sides. Once I do that, now I can do cross multiplying. 20 times x equals 15 times 16. 15 times 15 is 225, plus we have an extra 15, so 240. 20x equals 240. I don't want 20 x's, I want just one x, so I'll divide by 20. X is equal to 12. Five. Okay, I see how to set that up and I see how to solve it using cross multiplications. 3, I'm a little concerned about the setup, which one goes where and how to choose that, but I can solve it. 1, I can't set it up, I can't solve it, I feel complete. Okay, let me just look around. Okay, good. Hands down question.
What if it wouldn't matter if you did like 15 over x and 20 over 16, right?
Correct.
Okay, cool.
When you set up these proportions, you have to make sure that vertically they make sense. In other words, x and 15 are corresponding parts, and 16 and 20 are corresponding parts. You also have to make sure that horizontally they make sense. X and 16 have something in common. They're both part of this left triangle. 15 and 20 have something in common. They're both part of the right triangle. The ones that are diagonal, like x and 20, have nothing in common. X is this triangle's median, 20 is this triangle's edge. Would you please do number 2 yourselves now? Go. By the way, how do I know what matches with X? I could use my similarity statement, can't I? IH is the last 2 letters here, so which one matches with it? LK. And then if I want to pick another one from this triangle, I'd choose the 10 and I'd say, okay, that's JH. Well, I don't really have JH. J is between G and I, but I can see that it's this one. And LK in our case was 14. X and 10 are both the same triangle, and 14 and 8 are both the same triangle. So 8x equals 140. X equals 140 over 8. Divided by 2 is 70. Divided by 2 is 35. Divided by 2 is 17.5. Any questions on using proportions to solve for other similar parts of triangles? Okay. This is another kind of oddity of similar triangles. Please be quiet. This actually isn't 2 similar triangles at all. Yes, they do have an angle in common, but this angle doesn't necessarily match either of these angles. These are not 2 similar triangles. But if I do a triangle angle bisector, it turns out that it splits this side totally proportionally. So if I label this A and B and this C and D, if I look at the ratio of the lengths of these sides, A over B, that'll be exactly the same as the ratio of how this side gets split, C over D. So if A and B were the same, if this were an isosceles triangle, what would be the true thing about these bases? They'd be the same, be bisected. But if it's not isosceles, it splits them proportionally. So what I'd say for this one is 12 is to 4.8 as what? 18 is to x. Cross multiply, 12x equals 18 times 4.8. 18 times 5 would be 90. And then subtract 36. No, that's not right. 900 minus 36 is, someone with a calculator, please. Is it 864?
Yeah, it's 86.4.
86.4. Darn decimals. And then divide by 12.
7.2.
Thank you. So I would say to succeed with these problems, there's 3 steps. One is recognize what kind of problem it is. Is it an angle bisector? Is it a special part? Second step is set up the proportion. Make sure that you have 12 and 18 have something in common. They're both sides of the triangle. 4.8 and x, those are both split parts of the bottom. 12 and 4.8 are on the left side, 18 and x are on the right side. And then step 3 is cross multiply to solve. Any questions? Yes.
Why did you not do A over B? Like it was in the theorem.
I could have. And if I had done it that way, what I would have gotten is 12 over 18 equals 4.8 over x, right?
Yeah.
And notice what happens when I cross multiply. 12 times x still gives me 12x. 18 times 4.8. But you're right. I actually should have done it this way because this matches the formula. You're right. This would have been a better way to do it, but it'll come out the same. Okay. Second part for today. So this is supposed to represent 2 cubes. And because cubes all have the same number of lengths, right? This length is the same as the height, is the same as the depth. Length, same as height, same as depth. I know that these shapes are similar. What is the scale factor going from the 3 to the 5? Almost. Let's be clearer about it. We just do the image over the pre-image, right? So 5 over 3. 1.6, right? 1.66666, honestly. So leave it as a fraction, 5 over 3. Now, what if I calculated the area of this face?
25.
Good. This one would be 3 times 3 is 9. This one would be 25. So my ratio is 25 over 9. Now, if I had chosen a different length ratio, like the perimeter, for example, 3 times 4 would have been 12. 5 times 4 would have been 20. I did this in the beginning, right? That would be the same ratio because 20 over 12 reduces. Anything that measures a length in these 2 shapes and that represents the same thing, like this diagonal, if I like drew to the midpoint here and then drew back to the midpoint here, and I did the same thing here, whatever those lengths are, they'd be in that same length ratio. But what about the area ratio? Is it in the same ratio? Can I reduce 25/9 to be 5/3?
Yeah.
By doing what?
Oh.
5 times 5 over 3 times 3. Nothing cancels, does it? We're kind of tempted to square root the top and the bottom, but that's not allowed. That doesn't reduce a fraction. Just like we know that 1/4, if I square rooted it, would equal 1/2. Those aren't the same fraction, are they? No. So I cannot reduce 25/9. That is the most simplified form of it. And I guess that doesn't really surprise me, because if this side was 5/3 as big and this side is 5/3 as big, when I find the area, which is multiplying both of those together, my area ratio would be 5/3 times 5/3 as big. And what would happen if I did the volume? This volume would be 3 times 3 times 3, or 27. This volume would be 5 times 5 times 5 is 125. Good. 125 over 27. And that can't reduce. This is 5 times 5 times 5 over 3 times 3 times 3. The reason I'm showing you this is because for these problems, we're going to need this. We're going to say that the length ratio of any similar figures has a ratio, whatever it is, A over B. And anytime that's true, the ratio of corresponding areas will be what? How did we get from 5/3 to 25/9? A squared over B squared. And the volume ratio, the ratio of any corresponding volumes in those shapes, would be A cubed over B cubed. Now, sometimes these problems are going to be very straightforward. The perimeters of two similar polygons are in the ratio of 18 over 54. Find the ratio of the corresponding sides. What would be your answer? Well, is perimeter a length ratio?
Yeah.
And is corresponding sides also a length ratio? Yes, therefore the ratio will be the same. This is the answer. Could you reduce it? Sure, we know this is 6 times 3, 6 times 9. This is 3 times 1, 3 times 3. So the ratio is 1/3. Would it have been wrong to leave it as 18/54? No, it's the same ratio. It's just not simplified. So sometimes it's just the same. But what if we're not looking at the same type of measurement? Question?
Is that up top, you said AR, is AR area?
The area ratio.
Yeah, and then, so length ratio, is that only perimeter or are there any other?
There's lots of them. Anything that you would measure using a ruler is a length ratio. If you measure along one side, that's a length. If you measure across a diagonal, that's a length. If you measure this length and then this length and then this length, always using a ruler, all those are length measurements. And so the result would be like in inches or centimeters. On the other hand, if you multiply two together, you end up with inches squared or centimeters squared. And that would give you this squared relationship. If you do volume, which is 1 times 2 times a third measure, that would give you a cubic relationship, like cubic centimeters, cubic inches, cubic feet. So let's take a look at this one. Two triangles are similar. The smallest side of the first triangle, okay, sides, I like that. The smallest side of the second triangle is 36. So what's the ratio, just in your head? 1/3. So if you know the area of the first triangle is 100, what should be the area of the second one? A lot of us might say 300. That's wrong. Because this is area. So here's the way I suggest you do these problems. Step 1, always, always, always get yourself the LR, AR, and VR. Now, they're going to give us some ratio. In this case, they gave us the sides are 12 and 36. If we're looking at sides, is that a length ratio, an area ratio, or a volume ratio? Length. So I'm going to put that 12 over 36. Here is my LR. My life will be easier if I reduce it. How can I reduce 12/36? 1 times 12, 3 times 12. So this is 1/3. If that's my length ratio, A over B, what's my area ratio going to be? It would be 12 squared over 36 squared. Those are big numbers. Let's use the small one, the reduced one. 1 squared over 3 squared, or 1/9. What about my volume ratio? Good. It'd be 1 cubed over 3 cubed, which is 1/27th. This is like my toolbox. Bless you. For this problem, I get to use one of these ratios, the length area or volume ratio. Yes.
What do you think
I'm going there right now. So this first step with the LR, AR, VR sets up the problem. Do every single problem starting that way. Then I say, okay, what are they asking me to find? They're asking me to find the area. Is that LR, AR, or VR? AR. So this is the only one I care about. The LR and the VR were there just in case I needed them. I don't need them. What I need is the AR. 1/9. Now, in this case, the area of the first triangle is 100. So I'm going to put 100. Should I match that up with the 1 on top or with a 9 on the bottom? Yeah, it said the area of the first triangle is 100, and this smallest side of the first triangle was 12. We put the 12 on top. So I've now locked in that the first triangle is on top. I'm going to put 100 there. The second triangle is what I don't know. So I'll put an X there. Cross multiply to solve. 1 times X equals 900. So X equals 900 centimeters squared. Please try number 4 yourselves. Skip 3, go number 4. Okay, good. Are they giving you 2 numbers that are both associated with length measurements?
Yeah.
Yeah, so create a ratio.
on either side? Or no? Oh, you just do 24.
Yep. That's a ratio of corresponding parts because they're altitudes. And that gives you your L. Reduce it first.
And once I reduce it, that number like
Squared.
squared from each.
Right.
gives us
Area ratio.
scale, gives 3. Like,
Right. Raise it to the 3rd power. Good. Please check your answer with me. I got 120 meters squared. 5, I nailed it. I rule. 3, I got close. I can see the mistake. I can fix it next time. 1, I have no idea what I was supposed to do with that. Okay, hands down. Can I get somebody to explain what I did? Yeah, Sandra.
So just like in the first problem, you did the 24/16. And then you simplify that down to 3 halves.
How did I know it belongs in LR?
Because there's no like square over the meter.
Good indicator. Also the word altitude,
Yeah.
you measure with just a ruler.
And
Okay.
then after that, since you want to find the area, you square both the 3 and the 2. Get 9/4.
Good.
And then you would take the area of the first one, which is 270, and you put that over X, if you don't know the second one.
Good. How did I know to put the 270 on top and not on the bottom?
Because the altitude of the first is 9. And then altitude of the first is 9, and you know the area of it, but you don't know the area of the second one, which is on the bottom.
Right. When I created my length ratio, I did the first over the second. I could have done the second over the first, in which case I'd have to keep track of that. But in my case, I did the first 24 over the second 16. So I keep it the same, first over second. So they gave me the first, I put that on top. And then just cross multiply to solve. Thank you. Any other questions about that process? Let's show you a more challenging one. Take a look at number 5. How is that different? They don't give you a length ratio. So when they give us this first ratio, 36 over 49, I'm still going to start with LR, AR, VR, but what they give me goes where? AR. And that's supposed to be something squared. So you find the square root of 36 and the square root of 49. That tells me that the length ratio is 6/7. And the volume ratio would be 6 cubed over 7 cubed, which is 216 over 280 and 63, 343.
Yes.
Sorry, 216 over 343. And then look at the question. Find the ratio of the corresponding sides. Do they want us to create an answer with LR, AR, or VR? LR, because it's a side length. So 6/7 would be that ratio. 5, I think I get this stuff. This makes sense to me. 3, getting there. Got to do a little practice with it. 1, I'll never be able to do this. Okay. Good. Better scores. All right. Last piece for today. If I take a triangle, say this triangle. Wait, how many triangles are in this picture? 1 or 2? You see 2, or do you see 1 in a trapezoid? Good. I want to make sure we all see 2. There's 1 triangle. There's the other triangle. What do you know about these 2 triangles? They both share angle B. Excellent. So already I've got 1 angle pair that matches up. They do have parallel bases. How does that help us? If only we had like a transversal or something.
Oh, is there?
I think so. Isn't BA a transversal?
I was thinking BC.
BC also. If BC is our transversal, does that help us out?
Angle BDE or BAC.
True. BDE and BAC would have been the same. We talked about this transversal, so BED and BCA. Aren't those going to be the same? When I say the same, I mean congruent. Because if parallel lines cut by a transversal form, what kind of angles? That's the corresponding. Then the angles are congruent. So now we know that these 2 triangles have 2 angle pairs that are congruent. Therefore, the triangles are similar. And if the triangles are similar, then we know that the side lengths are proportional. Agreed? So I'm going to take you on a little journey here. Can you see how this is a similar picture to what we just did?
Yes.
Okay. I'm going to label this side little a, this side little b, this little piece down here, little c, and this little piece down here, little d. Now, you know how I'm going to talk to you guys in a little bit about advanced algebra or intermediate or algebra 1? I want you to watch what I do here. I'm going to derive a formula for you. Depending upon how confused you get in this derivation, that should be one more indicator about how your algebra skills stand. I'm going to break this triangle into two parts. My little triangle, my big triangle. How long is this piece? How long is this piece? B. How long is this piece? A plus C is the right answer. AC indicates, oops. What about this side? B plus D, good. Now, I now know that these two triangles are similar. We said that. And if they're similar, then that means corresponding parts of similar triangles are what? Are proportional. You'll see in your skills list that it talks about CPSTP. That's what this means. If I know the triangles are similar, then I can set up a proportion based on matching sides. So what would be the proportion I can set up here? A over B. Okay, you can do it that way. Or we could have done A over A plus C equals B over B plus D, right? Now, let's do some cross multiplying. So I'm going to have A times B plus D equals B times A plus C. I'd like you to look at, please, what you should get on this side. We should treat this as it's in parentheses, shouldn't we? And distribute this A across. Yep. If you didn't catch that parenthetic idea, that's another concern for the advanced algebra thing. Also, when I do B times A, multiplication is commutative. In other words, 2 times 3 is the same as 3 times 2. So I can write that as A times B. That way I see that there's an AB on both sides, and I can subtract that from both sides of the equation, leaving me with AD equals BC. Now, I'm interested in seeing the ratios of A and B. So what I'm going to do is I'm actually going to divide both sides by BD. You might not think to do that. That's okay. On this side, my D's cancel. On this side, my B's cancel. And I'm left with A over B is equal to C over D. This is our rule. And since I do this cross multiplication thing, like Satya was asking earlier about the ability to write it differently, I could also say that A is to C as B is to D. In other words, if I'm looking at these two triangles that are nested together, I don't have to take this whole side and compare it to little side A. I can actually just look at the new part, the additional part. A is to C as B is to D. So let's add that into our little notes over here. Let's call this A, this B, this C, and this D. If we know that DE is parallel to AC, then we know that A over C is equal to B over D. That proportion will be true and valid. And then the converse says, if A over C is equal to B over D, if they happen to be sliced in such a way that they're proportional, then the thing that's slicing them, the side that's splitting them, will be parallel. So number one, do we have parallel lines splitting these sides? Yes. Therefore, the way that the sides are split will be proportional. I can create a proportion between these two. 12 over 14 is equal to what? Good, 15 over x. Remember that 12 and 14 have something in common. They're both this top side. 15 and x have something different in common. They're both the bottom side. 12 and 15 have something in common. They're both part of the little triangle. 14 and X have something in common. They're both part of the swath down here. 12 and X have nothing in common. 15 and 14 have nothing in common. That's how I know the proportion's been set up correctly. Once I've set it up, I can do cross multiplying to solve. I divide by 12. 12 is the same as 3 times 2 times 2. So this becomes a 5, this becomes a 7, and then lowers 3.5, 15, 17.5.
How would you plug in the X value?
Same way, if you wanted to, you could even go back to what we just did here and treat it as two full triangles and say that 12 over 26 equals 15 over 15 plus 17.5, 32.5.
Oh.
Those should work out. What about number 3? What's our proportion going to be?
X over 36, 10 over 45.
Really good. Did you guys catch that 10 over 45? Why is it 10?
It's the entire length.
We don't want the whole length. We want just the matching little piece to X. Cross multiply to solve. We got 4 more problems here, the same. On the backside, we've got a very similar relationship. Picture that we just put a fictitious triangle up here. We did not only the single parallel line we talked about, but now another one. And it's going to do the same thing. If AB is parallel to CD and parallel to EF, what would you guess is the proportion? Well, we already know they're parallel, but this AC matches with which other part? BD, okay, we can do it that way. And that ratio will be the same as what? Good. Or you could have seen it differently. You could have said that AC is to CE as what? Yep. Either one of those would work the same. When you cross multiply, you get AC times DF and BC times BD. BC times CE, right? Okay. You have the rest of the period. It's 35 minutes or so to finish up this packet. Prepare yourself to wrap the unit up.